Good evening, my dear followers and subscribers. This is video number 397. In this video, I will explain correlation matrix and covariance matrix, its computation in STATA and SPSS, and their explanation. Here is the presentation scheme of this video lecture. I'll define correlation matrix, and after that I'll define covariance matrix. Then I'll compute correlation matrix in STATA and SPSS, and I'll interpret the correlation matrix. Similarly, I'll also compute the covariance matrix in STATA and SPSS, and then I'll interpret it, and finally I'll conclude this presentation. So the definition of correlation matrix is that it is a square table or a square matrix which shows the Pearson correlation coefficients between different pairs of variables in a data set. And I'll give you an example of a correlation matrix. You can see in this matrix these are the various correlations between various pairs of correlation. So I'll compute this in STATA, and then I'll interpret it later on. After defining correlation matrix, I'm going to define the covariance matrix. It's a matrix which is a square matrix, and it shows the covariances between different variables in a data set. And I would like to show an example of a covariance matrix, and in this table you see these are the variances and covariances of different variables. So after this I'll compute these two matrices, that is the correlation matrix and the covariance matrix, and then I'll interpret it. So the question is how to compute correlation matrix and variance covariance matrix in two softwares, that is STATA and SPSS. And for that purpose I would like to go to data. First I'll do that in STATA, and then I'll do that in SPSS. So here is my file. I have already opened it. So since I'm doing this video for the beginners, so I'll go step by step so that you people could follow me easily and understand. First I would like to make or compute the correlation matrix of various variables. So I'll go to pairwise correlations, click on that, and then I'll list the variables between which I'm going to compute correlation. So one of the variable is read, and it means that this is the reading score, this is the writing score, this is the score in mathematics, this is the score in science, and finally I have score of various students in social studies. So I'll click either on OK or on submit, and after this if I click on this, it will give me the significance level for each entry, and if I click this, it will give us significance level for displaying coefficients, and this will give me significance level for displaying with a star. So let me click on OK, and you can see this is how we compute correlation matrix between various variables. So in this table we can see that the values along the diagonal are equal to 1, and this one shows correlation. This is the correlation coefficient between read and read, and that is perfect positive correlation. This is a correlation coefficient between write and write. This is the correlation coefficient between math and math. This is the correlation coefficient between science and science, and this is the correlation coefficient between social study and social study. So the correlation of any variable with itself will always be equal to 1. So these values on the principal diagonal, these are equal to 1. But the values below the principal diagonal, these are the partial correlation coefficients between various pairs of variables. For example, 0.59 is the correlation coefficient between reading score and writing score. 0.6623 is the correlation coefficient between reading score and math score. This is the correlation coefficient between reading score and science. This is the correlation coefficient between reading and social studies. This is the correlation coefficient between writing and social studies. This is the correlation coefficient between writing and science, and this one is the correlation coefficient between writing score and mathematics. This is the correlation coefficient between math and science, and this is the correlation coefficient between math and social studies. And finally, this is the correlation coefficient between science and social studies. So if we analyze these partial correlation coefficients, they have star there, and this is the p-value related to each correlation coefficient, and all these stars and significance values or p-values shows that the correlation coefficients between various pairs of two variables are highly significant. So this is how we can do correlation matrix in STATA. Now I will go to the data again, and let me open the data. This time I am going to compute covariance matrix of the same variables. So here I have reading, here I have writing, this is math, this is science, and this is social studies. So there are 5 variables, and here is the option. Let me see the option. I want to display covariances. I will submit this, and now I have this matrix, which is the matrix of covariances. Now if you compare this matrix of covariances with the above matrix, that was matrix of correlation coefficients, the difference between the two is that the maximum correlation coefficient is equal to 1, and the rest of the values are less than 1, and all of them are positive. But here we see that these values are very high. So what do you mean by these values on the principal diagonal? So this value 105.123 is the variance of reading, or you can say this is the covariance of reading and reading. So the covariance of reading and reading means variance of reading. Similarly, this is the variance of writing, this is the variance of math, this is the variance of score in science, and this is the variance of score in social studies. The values below the principal diagonal, these are the covariances. 57.9967 is the covariance between reading score and writing score. 63.61 is the covariance between reading and math. 63.9693 is the covariance between reading and science. 68.41 is the covariance between reading and social studies. Similarly, all these other values are covariances between two different pairs of variables in the data set. Let me explain this one. 49.43 is the covariance between science and social studies, and this one is the covariance between math and science. This one is the covariance between between math and social studies. So this is how we can do correlation matrix and covariance matrix in STATA. I'm using the same data, and I can do the same in SPSS. This is exactly the same data. There are 200 observation on these various variables which are used in STATA. Now I'm using SPSS, and in SPSS I can do exactly the same thing, but the method would be different. So first I would like to go to the partial correlation coefficients, and I'll go to analyze and then go to correlate and bivariate, and let me also scoot science variable here and social studies, because previously I used the same 5 variables in STATA. Now I am using these variables in SPSS, but before clicking on OK, I'll click on the option, and I will check this one. This is already checked, so I would like to leave it as cross product deviations and covariances. Continue, and then I'll press OK. So this is the matrix. It gives us both the correlation matrix as well as the covariances in one table. So let me show the whole table to you. Okay, so this one, this one, this one, this one, and this one, these are the coefficient of correlations. This one shows correlation coefficient between social studies score and social studies score. This shows correlation coefficient between science and science. So these are along the principal diagonal, these are the values of correlation coefficient of variables with themselves. This is the correlation coefficient between social studies and math score. This is science score and math score. This is writing score and math score correlation coefficient. This is the correlation coefficient for reading score and math score. And this is the variance for math. This is the covariance for reading score and math. This is the covariance for writing score and math score. This is the covariance for science score and math score, and this is the covariance for social studies score and math score. So this is the square matrix which tells us both the variance, the covariances, and the various correlation coefficients between various pairs of the different variables in the data set. The only difference between now let me go back to the file, and I'll interpret, and the interpretation is that correlation means how two variables are correlated with each other, whereas covariances between various sets of variables show how two variables vary with each other. They may vary in the same direction, and they may vary in the opposite direction. If they vary in the same direction, the sign will be positive. If they vary in the opposite direction, the sign will be negative. So it only shows the covariance only shows the direction of variation between two variables, whereas correlation coefficient shows us both the direction as well as the magnitude of the relationship between the two variables. So ladies and gentlemen, this is how we compute variance matrix and covariance matrix in STATA and SPSS, and I also interpreted both of these matrices for you, and finally we can conclude that the correlation matrix only details correlation coefficients between various sets of variable in the data set, whereas the covariance matrix shows covariances and variances of different variables in the data set. If you haven't yet subscribed to this channel, kindly subscribe to the channel, and do not forget